will have the cran-cycloxyl diamine. That means that the double bond has to approach like this. Obviously, the big substituent has to be up in order to don't crash with the cran-cycloxyl diamine. And then the smaller substituent has to be over this hydrogen. That means that the smaller substituent has to be in this way. Okay, that I did it wrong here, sorry. Now I notice it. That means that the approach has to be just the opposite. Okay. That means that this has to be. Sorry for it. The approach has to be with the smaller substituent, that in this case is this hydrogen in over this hydrogen. Okay? And in the later case is exactly the same. Okay, if I remember well. Okay, this is the approach, and then depending if you consider which is the bigger substituent, if the bigger substituent is this, the approach has to be with this group over the hydrogen. If you consider that is the benzyl has to be this group has to be over the hydrogen. It's always the smaller group over the hydrogen. And I guess that I did it opposite. That means that if we do this approach, the approach has to be, if we consider that this is the bigger group, the approach has to be, okay, like this, with this benzyl over the hydrogen, because we consider that this is the smaller group. And if we do this, the final product is this. When I did it before, what I have to consider is that the bigger group is the benzyl and the smaller group is this. But again, if you justify which is the bigger group and which is the smaller group for you, will be okay. Right? Okay. Thank you for your attention. Please check it, how it's working, the Jacobsen epoxidation and the Sharpless epoxidation. Okay, the Sharpless epoxidation, probably the most difficult is the kinetic resolution. That means that please check how you have to grow your allylic alcohol in order to have fast epoxidation or slower epoxidation depending on the enantiomer that you are using. Okay? Thank you very much and see you soon.